Assalamualaikum and hi everyone. Before we start, I would like to provide you some scenario, a daily life scenario that we might come across. For instance, in a decision to buy a product, for example, some might believe that the higher the quality, the higher the price will be. Or another example, some might believe that the more hours you spend for study, the higher the grade you will get. So in these two scenario, actually we are talking about the relationship between the two variable. The first scenario is basically a relationship between the quality and the price, and the second scenario basically the relationship between the time of studies and the grade that you will get. So in statistics, we call it the analysis of correlation and also analysis of regression. So in this topic, I will divide the video into four parts. The first part is introduction to simple regression. Second part is hypothesis testing for simple regression. The third part is the basic assumption for regression, and the final part, the fourth one, is hypothesis testing for multiple regression. So let's go to the first part of my presentation, which is on introduction to regression analysis. I would like to start the lecture by highlighting some business issues that are relevant to our course. First issues, for example, is there a relationship between the price of product and the net hourly wages of workers in apparel industry? If so, how strong is the relationship? Second issue, is there a relationship between training and number of defect products? And the last one, is it possible to develop a model to predict the online sales in social media by the number of likes? If so, how good is the model? So when we are dealing with this kind of issues, we are actually talking about two issues. The first one is about the relationship, and the second one is about the prediction. Actually, there are certain ways to identify the pattern of relationship between two variables. First, by having a scatter plot or scatter diagram. This diagram will show the relationship between the two variables. For example, here in the first diagram, we can see that as the x value increase further, the y value also increase together. The second diagram showing that as the x value increase, the y value will decrease. And the last diagram here showing that there is no clear indication of to what extent the x increase and the y will also increase or decrease, which shows that there is no correlation. So this is the first step, knowing the pattern of relationship. Next, we may want to go further to measure the strength of the relationship. Then we have to conduct the correlation analysis. In addition to scatterplot and correlation, we also can run a regression analysis. By doing a regression analysis, we can do prediction and we can measure the impact of changes in dependent variable when the independent variable change or being manipulated. In regression, we have to identify two variables. The first one is dependent variable, which is the variable we wish to predict or explain. The second variable is independent variable x, which is the variable used to predict or explain the dependent variable. Let's look on this example. Maybe we have some question. Is there a relationship between online sales in social media and the number of likes? So logically, in this scenario, dependent variable is basically the sales, because sale can be predicted or can be explained by the number of likes. So sale basically is dependent variable or y, and number of likes is basically independent variable or x. In regression, we are measuring the strength of the relationship, and we also do the model building for prediction purpose. Here is the formula for the regression model building. Y hat equal to beta naught plus beta 1s and x1 plus the errors. Okay, so this is the formula to develop a regression model. When we run the regression analysis, there will be some type of relationship that we might found. For example, strong relationship. Based on this diagram, we can observe that the each of the data, the red one here, is very close to the average line, the blue line. The blue line is basically the regression line. So when each of the data is very close to the regression line, the relationship is very strong. Okay, because the variance is small. In this example, the relationship is basically positive because when x increase, y will increase together. So positive and strong relationship. The second type of relationship is very weak relationship. For example, here each of the data, the red one, basically is spread out. This data are far away from the average line, the blue line here. Okay, each of the data is far away from the regression line, meaning that the variation is relatively big compared to the first diagram here. So because of that, the relationship is weak. Or maybe we also can have another scenario, no relationship at all, as we can see here. Okay, when we see the overall pattern, it seems like, okay, when the x increase further, the y basically remain, not increase or not decrease, so remain. So this is what we call no relationship at all. This is basically the scatter diagram that we developed in the first place, and then from here we can develop the regression model. So this is the formula for the regression model. Okay, so based on this regression model, y equal to beta naught, here is the intersection, beta naught is the intersection, plus beta 1 here. Beta 1 is basically representing the slope. Okay, slopes means that we can see the changes of y when x being manipulated or x increase or decrease. So how much y will be affected, that will be shown by the slope here, the beta 1 value. Okay, so this regression line basically provide the estimate of the population regression line. This is the formula, this is the interpretation. Y hat meaning that the estimated value of y. Beta naught is basically the estimate of the regression intercept when x is 0, what is the value of y. Okay, this is beta naught. Beta 1 is estimate of the regression slope, as I mentioned before. Okay, this is the x value. Let's go to this example. Let's say we have this scenario. Okay, a quality manager wish to examine the relationship between the number of quality inspection and customer satisfaction. So relationship between the number of quality inspection and customer satisfaction. So a random sample of 10 product is selected, for example, and here the dependent variable is customer satisfaction index, and the independent variable is number of quality inspection. We believe that theoretically it is logic to assume that customers satisfaction will depending on the number of quality inspection at the factory, for example. The more we do the inspection, the less we will deliver the defect product to the customer. So because of that, the customer will more satisfied and satisfied. Okay, so that is the logical relationship. So first, in our Excel, we have to key in the data, one column for data for quality inspection, the second column for customer satisfaction index. Okay, from here, first we will produce the scatter diagram. The purpose is producing this diagram is that first we want to see the overall picture of the pattern of relationship. Is there any indication that there is a pattern of relationship, maybe positive, maybe negative, or maybe no relationship at all? We are not going to see the strength of the relationship yet, but just we want to see the overall pattern. Okay, once, for example, like this, once we know that there are some indication that the positive will be linear and positive, the next question is that we want to know if the relationship is positive like this. We want to know the strength. Then we will go to the deeper analysis. So this is how we run the regression analysis using Excel. First, we key in the data. First column, data on quality inspection, 10, 15 until 13. Second column, we type customer satisfaction, starting from 75 to 76. So to produce the scatter plot, what you need to do is that you highlight the data here, then go to Insert tab, go to here, Scatter, pick this one. Okay, so this is how the scatter plot will looks like. Okay, then after we observe the pattern, we can do the regression analysis to measure the strength of the relationship. Okay, and then here there is a data analysis tab here. Click. Okay, so we choose here regression here, regression, and then OK. Next, for the input for Y, we select here Y is customer satisfaction. Then we go for input for X. We select here quality inspection. We tick the label because we in the range here we include the QI and CS, so we click the label, confidence interval, confidence level. Okay, 95% correct. Okay, Next, we have to put where we want to have the output. Okay, for example, we want to have it here, then be okay. Tada! So this is the result that we get. So that's all, very simple. So once we run the Excel, the analysis will produce the output. So this is the output from the Excel analysis using the regression function. Okay. So here we have basically three parts. Okay. The first is basically the summary of regression statistics here. This is what we call it first part. Second part is result for the ANOVA test. And the third part here is basically the consists of the coefficient value for intercept for the beta node and also for the beta 1, which is quality inspection, and also the t statistic, p value, so on and so forth. Okay, so once we have this information, the output, which we have to interpret. But before that, let's see. This is the regression line that also can be produced by Excel. From here, we know that how the regression line will looks like. Okay, and if we connect the line here, the regression line, okay, up to here, we can see that here is basically they will stop at this at 56 something. This is basically the beta node or the A value. Okay, so this is how the regression line will looks like. Okay, now come to this interpretation. Okay, so based on this information, as we know that we should produce the regression equation. This is the formula y equal to beta naught plus beta 1 x. Y is customer satisfaction equal to, so now beta naught and b1. Beta naught is 56.28. Okay, so how we got this? The beta naught 56.28 we take from this. The intercept is the beta naught. This is the value. Okay, this is the intersection 56 point something. Okay, next, this is how we interpret beta naught is basically the estimate average value of customer satisfaction when quality inspection is 0. So if we are not doing the interpretation, if we are not doing any quality inspection, we will assume and estimate that the customer satisfaction index will be around 56.28 when the quality inspection is absent or 0. Okay, so this is the beta naught. Now beta 1 is basically 1.911. So where we got this value? This Q1, yeah, sorry, quality inspection. This is the coefficient. Coefficient here is basically the beta 1 here, 1.91 something. So this is the equation, the regression equation. 1.911 basically is the here. This is the slope here. So this is the interpretation for the beta 1. Okay, the mean value of customer satisfaction increased by 1.911 on average for each additional unit, for each additional 1 unit of quality inspection. That's how we interpret the beta 1 value. Next one, we have this equation perfectly. We can do the prediction. Okay, let's say we want to predict the customer satisfaction index or the score when the number of quality inspection that conducted is around 6, for example. Okay, so when the number of quality inspection is 6, we put it here, x, the value of x we replace with the 6 here. Then by calculation we can predict that the customer satisfaction score or the customer satisfaction index will be 65.84 when the quality inspection is 6. Okay, so that's how we do the prediction. Please take note that when we are making prediction, okay, for the x value, yes, we can put any number, but be careful that the number that we can put is only in between the minimum and maximum number of our data set. We cannot put the x value when we make prediction beyond the range of our data set. For example, in our data set, the minimum value is 5, the maximum value is 17. So when we want to make prediction, the x value must not less than 5, and also the x value must not more than 17. Okay, so do not try to extrapolate beyond range of the observed x. So that you have to remember. Once we know this regression equation, directs that we also can measure the strength of the relationship between x and y. So basically, this is the R value. We call it correlation coefficient, represented by R value. So when we calculate the the correlation coefficient, the value basically will be in between -1 up to +1. So this is how we are going to interpret. If we got 0, it means no linear relationship. If we got exactly +1, that means we have perfect positive linear relationship. Or if we have perfect -1.0, it means perfect negative linear relationship. If between 0 to 0.3, whether it is positive or negative, the relationship is very weak. If the relationship between the R value is between 0.3 to 0.7, we can say that the relationship is moderate. If 0.7 and above, we can say that the relationship is strong. For example, in our result just now, we look on this value multiple R. This is the basically refer to the coefficient correlation coefficient R, which is 0.56. 0.56, we can interpret that we have a strong positive relationship. Okay. Next, we also can measure the variation. Okay. So in measuring this variation, basically we want to know to what extent, okay, the dependent variable can be explained by the independent variable. So here is another measures, we call it coefficient of determination, which is R squared, and the value of R squared will be between 0 to 1. Okay. So by definition, the R square is the portion of the total variation in the dependent variable that is explained by the variation in the independent variable. So it shows the power of explanation by x variable, okay, in explaining y variables. So let's look back this statistical output. Okay, so from here, where the R square that we can get. Okay, so this is the R square, 0.726. By calculation, basically we have two options. First is that by using the SSR divided by SST, as shown here. Okay, this is the first option. We can get from the ANOVA table here, SSR here, sum of squared regression 541.14 divided by SST here, sum of squared total variance 744. So this is how we get 0.7269. Another option is that very simple. R square, this is the R value, we just square the value, 0.85, we square the value, that one will become 0.726 somethings. Okay, now come to interpretation. 0.7269, so we have to convert to the percent to make it easy for us to understand. So we times 100, now become 72.69%. So how to interpret is the interpretation is 72.69% of the variation in customer satisfaction is explained by the variation in quality inspection. Okay, so that shows how big the quality inspection bring effect to the customer satisfactions. Um, the next issue is how good the regression line in doing the prediction. So we can answer that question by measuring or calculating the standard error of the estimate. Standard error basically refer to the standard deviation of the variation of observation around the regression line, and it is estimated by this formula. Okay. Um, in terms of interpretation, okay, it is very straightforward. Okay, the smaller the value of standard error, basically the better the prediction. Because of what? It's just because of the variation of the data that scattered around the prediction line is so small. So once we have, for example, a larger value of standard error, so it means that the variation of the data scattered around the prediction line is bigger, so the prediction may not be as good as if we compare to the if we have a small standard error. So back to our example here, the standard error is 5.04. So if we compare to the raw data that we have, which is the range of the customer satisfaction score is in between 65 to 90. So 5 is basically small relative to this range of customer satisfaction score. So the standard error basically we can say that it is small. It means that our prediction, our regression line is good. Okay. So now this is another scenario showing that okay, when the standard error will be small and when the standard error will be large. For example, here on our left side here, as I said before, when each of the data, look at the red one, very close, located very close to the regression line, that will produce the small standard error. And then another scenario, when we observe data, okay, the red one second located okay far away compared to the regression line, that will produce larger standard error. Okay, so this is for my first part of presentation for simple regression. See you in the second part. Thank you very much.